That sounds like one of those. And this is why ACM is not allowed to do all the things anymore. Pretty much.
After Malcolm got involved.
Sorry.
Well, as far as the law.
I was watching your call for this.
The
entire time.
So today let's talk about some of the features we find in most programming languages. This is more a theoretical topic. Let's try to make it as a conversation to hear your opinion too, based on your own experiences with using different programming languages. You will find this topic in a specific chapter in the textbook. I think it's important because it shows it adds terminology for our discussion of programming languages, and also talks about some of the features in that we can use to compare different programming languages. The first question is, what makes a good programming language? This is like an open question. Why don't you guys talk with each other in your groups, and then we can have a conversation as a class. Let's say 2 or 3 minutes.
That's number one. She did this whole
a good programming language is clearly
yeah, I did all the good stuff.
preserve words.
Yeah, yeah. I absolutely agree. I feel like it's oddly important. We all know the majority. And like healthcare options. On that note, have you guys identify issues? At least from like a financial perspective. Like, they don't even tell you, oh, you're selling this here. They'll tell you like, yeah, you did this here, and then you did this here. They're trying to have system. And the thing is, it works. Yes, you know how they. Yeah, and so it's like a organization. What a problem. Yeah, one of these days it's gonna get like as people smarter, like more expensive over the long years. What's else favorite? Does he pull it every time it could be I learned on JavaScript just thinking that
The United States government.
I miss it. Yeah. I love using Java. Yeah, probably use Java or Python. You guys seniors? Like, understand. That's true. Do y'all have operating systems? Yeah, programming up in the same boat. Local languages, the syntax was very similar to words instead of like 3 characters. So user readability, I guess. Python feels like an equal teacher that like is so unstructured that like it's slow because I'm so unstructured. But I'm like, no, I want semicolons.
Because you're maintaining
I want my brackets and
existing system. Right, yeah, and like an online
so
does not require.
I like the UI. I love something that
I like Java.
brackets.
Sources
and annotation.
Whenever I have to study.
Yeah, I think all three of us understand. Everybody knows that.
Yeah, I would say readability is like right at the top. Another person can come over and understand.
All right, let's hear what you have to say. How about you guys here? You guys think there's a good
Syntax.
clean syntax?
Easy to read. Understand.
Good one. Good one. Another one. You guys there?
Scalability. So
Scalability.
being able to work on, have it work on a small scale, and also be able to use it on a large scale.
For larger
That
projects.
can continue to expand and improve on it without totally destroying everything.
So a programming language that you would be able to use for a small project and even for a large, complex software.
Or even better, if you can, over time, the small project can grow into large, complex software without having to migrate.
Awesome. That's an important feature. How about you guys in the back?
I feel like readability.
Readability.
It allows for larger projects with larger amounts of workforces that can read each other's code. And even for your own debugging process, which we all know is 90% of coding, that actually accelerates it.
Awesome. Readability is one of the most important characteristics we want in a programming language. Excellent.
It has official style guides that have uniformity.
So you kind of expect when you read a code, you kind of expect to see the same type of style because the way the programming language drives you to those styles. How about you guys? Easy to learn, right? Easy to learn. That helps the programming language, especially when it's a new programming language, right? You want to learn, gets more, because we also want, we don't want the programming language that only us use, right? Something that it's not popular, because if it's only just a few people using, you probably are not going to find a lot of documentation, support, right? When you have a problem. So all those things are important. Anything else, you guys on that? Yes.
Community.
Huh?
Community.
Community support, right? Like extending what I said, right? The support of the community is very important, right? Especially when you're learning, right? Or when you need to meet that tight deadline, right? And you have to find out what's going on, figure out that bug, and if you have a community support, that's very helpful. Great, awesome. So some of the things you mentioned, they're kind of structured here. If I can make this. Oh, that's too much. All right, so you have some characteristics, and then you're going to evaluate according to these big criteria, the three most important: the readability, writability. So readability, of course, it's the ability to read the code and understand easily. Writability, how easy it is to write the code, right? And reliability, right? So the ability to write a code that is reliable. So some of the things, some of these criteria, they will be supported by these characteristics on this column here. So if programming language is, it has simplicity as one of its characteristics, it usually will have good readability, good writability, and good reliability as well. So let's evaluate some of these characteristics a little bit deeper and see if you can make these associations. Okay. So reliability is that talks about the code that is reliable, that is safe, right? So, for example, if the program, so you're going to find, in order to support this criterion here, reliability, you pretty much will need to find all these things, right? That's what this table is trying to tell us. So let's start with, before we actually talk about the characteristics, why readability is important and when people started to realize its importance or started to take more that into consideration, right? So I think I mentioned that in the around the late 60s and beginning of the 70s, that was a crucial point where the price of hardware it wasn't as significant in terms of the price of the software as the price of the solution you were trying to build. Up to that time, the most important component was the hardware. Hardware was the expensive part, and by around that time, late 60s, beginning of the 70s, that's when personal computers became popular, and that's when the price of the hardware wasn't a big component anymore in a software solution. The software itself, especially maintaining the software, that was the big cuts in the price. So people started to invest more time in trying to make a software with better quality, with better features like readability, for example. Because if I can't read the code, how am I supposed to maintain that code and find errors and correct those errors if I have a hard time understanding, right, what the code is doing? So the software development life cycle, people started to talk about those things, and also the traditional way to do it at that time was, I don't know if you guys heard in software engineering, the waterfall methodology. So that was very popular at that time. And you just, waterfall model is that you spend a lot of time on each of those phases, but usually you don't go back once you start the new phase. And as you know, this is not the way we do software now, because requirements change all the time, right? And we want something that we want a development life cycle that is constant in an evolution, right? Because things change much rapidly nowadays than what it used to be. The writability criterion measures how easy a programming language can be used to create programs for a chosen problem domain, right? So how easy it is to write the code. So this is what this criterion is trying to tell us. And finally, reliability, as I said, is a program is said to be reliable if it performs to its specification under different conditions, different platforms, input. So it's a software that expects, that behaves as expected. The easier a program is to write, the more likely it is to be correct. Kind of obvious. And programs that are difficult to read are also difficult both to write and modify. So all these things, they are interrelated. So let's talk about these characteristics. And as I said, readability is something that impacts the quality of your software. And it was something that people started to take more into consideration in the 70s, when the price of the hardware it became not a big part of the software solution cost. Software became the part that was expensive. They needed to improve the quality of that software that's being produced. So what makes the programming language simple, right? So we like to say, usually we don't tend to think that, oh, I don't want a programming language that is simple, right? We want something that usually most students in the beginning, they have the sense that, oh, if the programming is simple, I can't do much, right? But this is a misconception, okay? The fact that the programming language is simple doesn't mean it's not powerful, okay? So simplicity has to do with the number of constructs, right? So larger programming languages, so they are not simple because they have a large number of constructs. What happens is that they often end up having overlooked features, right? So if the programming language has many things, but people will not use all those things that are there. It's like if you buy an expensive car with many features and sensors. For example, I don't have not saying that I have an expensive car, but I know that my car, and most cars nowadays, they have the cruise control, right? How many times do you actually use the cruise control, right? Hardly ever. I don't even know how to use them.
Cross-country road trip is the only time.
Yeah.
And then it's
Anytime you're not in traffic, so I guess nowhere within the Denver
Yeah,
metropolitan
no.
area. But
nowhere I ever drive.
Does anyone ever use like the drive 1, drive 2 things at the very bottom of your stick shift, even for automatic
I'm
cars?
scared to use those.
Okay, I feel like that's like an overlooked feature, as like the
Yeah.
DR1.
Like going downhill.
Yeah,
Use
just
it.
feel entry
Yeah, you
brake.
downshift and you're heading down.
That's how you mentioned braking on automatic.
I just-
Okay.
Way too much fader in my car.
Brake is my stick shift.
Yeah, I mean, I guess it was a good analogy, right?
It has a negative.
Well, let's go back to programming language.
Insert car park.
That's good to know though, because Colorado does have a lot
For
of those
example,
steep grades down.
You guys are familiar with Java, right? Have you ever used Java's double brace initialization? It's a feature that allows you to write expressions to create initialized collections. Use double braces. It's something that it's available, but it's not. I have the impression that it's not used very often because people don't even know that this feature exists. Here's an example. Right, so I want to initialize a hash set, and I want to call add as I initialize the hash set. So this is the syntax to do that. It's something that is available, but maybe 10% or less of the people know that this feature exists.
Nobody uses like more than Java 8 in the real world, right? Everybody's stuck on 8, right?
Stuff what?
Stuck using 8, Java 8.
Java, oh yeah, people are not using Java anymore. Okay. I think Java is still going to be around for a long time. There's a lot of code already out there, so it will take centuries, I believe, for Java to go away. Another example, did you know that you can name a slice in Python?
What happens when you run that?
So for example, I'm giving a name for a slice, and then I can refer to that slice using that name in different parts of the code.
Maybe I'm not super familiar with Python, so what does the slice do?
Oh, so slice allows you to take like a virtual vision of your collection, right? So this slice here is doing -3, so it's coming -1 is this, -2 is this, -3 is this. So it starts at -3 and go to the end. So I'm taking this vision of the list, and I'm calling that last 3.
So it's the last 3 of that list?
Yes.
Okay.
Yes, right? So, and now I can, I want to do something like last 3 index 0, I will be referring to this number here. And if I modify the slice, I actually be modifying the inner array or this. Okay? So there you go. Slice might be something that is a feature that many people don't know about it. And this is even going one step further. You can name the slices, right? So another thing that you would say that programming language will be a little bit more complex if you start adding feature multiplicity. So feature multiplicity is the ability to accomplish the same thing different using slightly different syntax. Okay. So for example, there's different ways to increment a variable. For example, in C and Java, you can do that. So you can do count plus 1, or count plus equal using this operator. And then you can do plus plus, or plus plus prefix or postfix. And these, if these were statements, isolated statements, all of these will have the same effect on the variable count. So this is feature multiplicity, the ability to do the same thing different ways. So if our programming language wants to be simple, it should only allow one way to do some specific operation. That makes the programming language simpler. Okay? And if it's simpler, it reads better, because if you have a team, let's say 4 people, right? Oh, I like this one better. Oh, I prefer this. No, I'd rather do this one. So each of you will be doing differently the same operation. And if you're working on the same project, you're gonna have, you always have to think, oh, he's trying to, this is a very simple example, but think of that in something more complex, right? Or something not as obvious as that, but each of us will be doing differently. Okay, it's good, we think differently, right? But it's such a simple operation, why not just do the same way, right? So I know this is not, I don't expect that you all agree with what I'm saying. I'm just trying to create a conversation here and talk about these things, right? What makes a programming language simple? Another thing, it's kind of the opposite of operator feature multiplicity. Operator overloading. Operator overloading, now you're going to use the same symbol with different semantics, right? So for the classic example is the symbol for addition to do arithmetic operations. But you can also do that in some programming languages, I believe most programming languages now, to do concatenation, right? So it's different semantics, but the same operator. So a programming language that wants to be simpler, it will not allow you, or will restrict those type of things. But I like operator overload. I'm a big fan of operator overload. And most of the times, the context allows us to easily distinguish between the uses, right? So I don't think it creates a readability problem. What do you guys think? Do you ever be in a situation where you had to think more than half of a second whether the expression was arithmetic or concatenation?
No.
I've never been in a situation like that, right?
Only when I did it myself.
Huh?
Only when I implemented it myself.
I feel like where it could create a problem is in like writability on the margins. Like if you were learning a new language that either did or didn't have that ability.
Yeah,
So
so
you-
you're trying to use that and you don't know if that is available or not, right? Yeah, I agree. And then you continue what Letitia was talking about. How about you want to go one step further? Like, can I use the symbol to concatenate lists, collections, for example, right? But what if I'm doing using the symbol with different, like a collection and a scalar value? Would the scalar value be transformed into a unit collection and then do the concatenation, or it will add the scalar to each of the elements of the collection? So depends on the implementation, right? So operator overloading has this problem. As Leticia was talking about, writability, right? Can I use that? What's the semantic? I have to look at the documentation, right? And by the way, what do you guys think Python will do? For example, can I concatenate lists in Python? Do you think this part will work and will do what? Do you think it will add each of the elements, correspondent elements, or will concatenate the collections? Raise your hand if you think it will concatenate. Yeah, you're right, it concatenates. How about this? Do you think it will work? You have a collection and a scalar value, an integer. Do you think it will not compile? Do you think it will turn that into a collection with number 1 and then create 0, 1, 2, 1? Right? Or do you think it will add 1 to 0, so it will be 1, 2, 3? What do you think?
1, 2, 3.
I think it will not run.
That's an error.
It won't? No.
Tried to do that, it didn't work.
Someone try to do it now. I
Oh,
don't
yeah,
think it
you have
will.
to, yeah.
Okay.
If you put it in brackets, then it.
But it might work in a different programming language, okay?
Just use NumPy.
I don't want to hear that word again.
Yeah, but NumPy is a library, right? So it's adding features that allows you to operate it with a different collection, like the arrays, right? NumPy arrays. But that's different. This is the example here was implemented by the language. It's part of the programming language. Simple languages are easier to learn. You guys all agree with that? It doesn't have a lot of operator overloading. There's only one way to do stuff, right? It doesn't have many constructs to pick, right? So it's easier to learn. But do you think that just because it's simpler, do you think it's less powerful? It doesn't. It doesn't. That's you can't infer that, right? Be careful not to carry the concept too far. So, for example, if you think assembly language, they are simple, right? In the sense that you basically have to use the same instructions to do specific operations, right? You don't have a lot of room for different things, but you think that's easy to read, right? It's horrible, right? So you have to understand that it doesn't directly, just because it's simple, it doesn't mean it's easy to read, easy to write. Okay. So another feature is called orthogonality. So in just one sentence, orthogonality has to do with are there exceptions or not, right? So usually you're gonna find exceptions of the general rule when you try to combine constructs to build other constructs. That's when orthogonality it's important. So a language is orthogonal if its features are built upon a small, mutually independent set of primitive operations. So it's usually programming languages that are highly orthogonal. They have a very clean design and allows you to combine simple constructs to build more complex constructs. And there are few exceptions to do those things. So they're conceptually simple, having fewer exception rules. So let's see some examples. And I'm gonna show these examples by criticizing a specific programming language that you guys should be a little bit familiar with, C. You guys do C in 1400, 2400, you did a little bit, right? So, yeah, okay. Operating systems too, great. So, examples of lack of orthogonality in C, okay? So, the arrays and structs are the only two structured data types available in C. So, C is not object-oriented, right? So you don't have the class construct, but you can create static arrays using the brackets to create arrays. And you can also create records called structs. I don't know if you guys use structs in C when you learn C, but basically think of a struct as a class without methods. Basically, it only has the data type portion of a class. It's called struct. The way you use, so these are two ways to create structured data types, right? Because arrays, you're creating it's a data type because it's a collection of elements. And struct is also a collection, but not a collection, but it's a data type because you can specify different types within that data structure. C, for some reason, when you create a function, you can return a struct, but you can't return an array. So it's like an exception when they define the syntax of how you define a function in C, they said the return cannot be an array, right? There's no particular reason why can't you return an array from a function. So that's an example of like an exception of the rule. When you create a function, you can't return an array. Well, there is kind of a reason. If you want to define a function that does something with an array, or it needs to return an array, arrays in C are basically pointers, right? So basically what you need to do is define a specific parameter for that array, right? That needs to be returned. So basically your function needs to return an array, it needs to define the array as a parameter. That's how you kind of return the array. Another example, void is considered a type in C, but you can only use void in particular contexts, not all contexts. For example, you cannot use void. You cannot define a pointer to void, use point to define a field in a struct. So there are some limitations on how to use void. And void is basically used to define a function that doesn't return a specific value. Say the function is void. But that's another example of an exceptional rule. Arrays variables, so you can define a variable to be of an array type, and you cannot assign an array to another array variable. Like if you wanna do that, you have to create another array, copy all the elements. There isn't an easy way just to assign an array variable to another array variable. So although you can do that with any other type of arrays or variables, you can't do with arrays. So that's another example of an exceptional rule. When a programming language has many exceptions, don't you agree that makes it harder to learn, right? Because you need to memorize those exceptions, right? Can you think about examples in real life of lack of orthogonality in real life? Trying to come up with some real-world examples to facilitate comprehension of these concepts that are more abstract. I had an example, trying to remember now. It has something to do with the TV control. It will come up. If I remember, I will. No, I'll try to remember that. It's not coming right now. Examples of lack of orthogonality in Java. There are two categories in Java. Primitive, so you have primitive types, right? And you have the built-in, primitive are built-in, and then you have the user-defined, which are the class types, right? What if you can define, of course, user-defined, you can define class, right? But what if you want to create a built-in type, right? A primitive type. So there is no way to create a primitive type. Like you want to create a different type. Well, we understand why you can't, right? But this distinction just makes it a little bit harder for when you start learning. Remember, when you start learning Java, you have to understand that, okay, there's these class of, this group of types that they come with Java, right? But I can define my own if I create class types, right? But I can only create class types. These guys here, they come with Java. So I have to accept them, right? So it's just another example of an exceptional rule. But the key is orthogonality to be strict. Like I want my programming language to be super orthogonal and have no exceptional rules. Will allows a lot of freedom, right, for the people that use my language. Well, if I do that, it ends up that my language will be very complex to implement. Okay, so designers of programming language, they trade off orthogonality, create exceptional rules to make their implementation more efficient. That's exactly the thing with the primitive types. The primitive types are made to match the types that are supported by your computer, right? They match the types that your machine supports, right? So for example, the floating point maps the floating point implementation of the standard that most computers support those types, right? In their at the low level, right? So it makes sense to define those primitive types that are very efficient and map directly to your computer low-level types. much orthogonality can negatively influence writability, because if you give users, your programmers, too much freedom, they will come up with some combination that will not even make sense. So, I'm not gonna even go into there, but just keep in mind that you can't, all of these things you can't carry too far away, otherwise you create something that it's like a monster, right? Data types are basically saying that it's important that programming languages have data types. The lack of types for commonly used values certainly impacts a programming language readability, reliability, right? So we take for granted now that most programming languages will have types for numerical values, for strings, right? And some programming languages will have a specific type for Boolean values. We can live without that. We can use an int, 0 or 1, like C used, right? But we kind of expect those types to be available. We need types for basic collections, right? Things that are basic, they come with the language, and they provide mechanisms that allows you to create your own types. And finally, syntax design is the form, while semantics is the meaning. A well-designed programming language, semantics, it follows directly from syntax. So the syntax, remember, is the way you write, right? So the structure of how you structure a sentence, a statement, this is syntax. The semantics is the meaning. What would that happen if I write that syntax, right? And what it's saying there is that a well-designed programming language, the meaning of what you write should be kind of obvious from the way you write, right? So the syntax, it kind of makes you infer, even if it's the first time you're reading that statement in a new programming language, if it's well designed, you will understand what you're trying to accomplish. So the syntax supports the semantics. Here are some examples of bad situations where syntax didn't help our understanding, right? So for example, the C programming language, the static keyword has different semantics depending on the context. But they carry that too far away. Like, for example, if you use static inside a function, it means that a variable is to be defined at compile time. We're going to talk about those things, binding of variables later. But basically, the function will hold the value of that variable between calls if the variable is defined as static. Sometimes this is important. But another use, if it's used outside functions, it means that a variable shall not be exported from the file where it was created, right? So a complete different semantic, right, has nothing to do with what is said before. But they wanted to use the same keyword, basically, for completely different meanings.
Why would they do that?
Design flaws, right? They thought about using the same thing, but they thought the semantic was obvious, but sometimes they made mistakes. Hopefully, we're never going to see someone trying to create if statement in a new programming language using some keyword different than if, because if is so established, right? We already know what an if means, right? The same for while, for, right? So those things are pretty much established. We all understand the semantics associated with those syntax. So hopefully people will not try to be creative and come up with different names for things we already know, right? That would be really stupid. So different syntax here for defining compound statements when you have groups of statements. Basically, Python innovated in the sense that use the tabs. Do you guys like the tabbing of Python to define scope?
I think on a small scale, it's really helpful, but I found that for anything larger, it can get kind of tricky.
Yeah, I'm very visual, and I like I would prefer the braces, something physical in the code, right? Something I can actually see. But it's people got used to, right, with the tab. The advantage of the tab. What do you think is the big advantage of tabbing in Python? Other than you have to do it, but what's the big advantage? You don't have to keep track of the records.
It's less lines of code.
Readability, and why is that?
You're forced to tab.
Exactly. So you force your block to be tabbed, right? That was really smart. I think, right? So they kind of force your code to read better because you have to put the tab, right? So it was an interesting solution, but the fact is you don't see but the code is aligned, right? So, I mean, I can go either way. I'm a big fan of Python, so anyway. Expressivity. So it's another important vocabulary for you guys, programming language. So the idea is that you can do a lot with less, right? So you can accomplish something, but you don't have to write a lot of code to accomplish that thing. Like measure how simple it is to express an idea, write a program. And I think, in my opinion, this is one of the most important things we want. I think it's, I like the fact that, for example, Python is known to be very, to have this feature, right? You don't have to write a lot compared to other languages. I don't know if you guys agree, but in Java, it's like the opposite, right? So if you want to write a program to just print hello in Java. How many lines you have to write, right? So not a lot of expressivity. And I have the example here, right? So you have to write all of that to do this. Okay, so that's visually you can see that Python has more expressivity. Now let's start. All of these things that I mentioned, they are important to create a code that is reliable, because a code to be reliable, you have to, it needs to be easy to read, it needs to be easy to write. But there are other things that are specific, important for a code to be reliable. One of the things is type checking. So if your programming language has a compiler that, or the programming language itself forces you to do certain things, and you have a compiler that checks those things, it ends up that your code was going to be more reliable. Okay, so type checking is an important thing that makes the programming language more reliable. And for example, the C programming language very flexible. You could go low level, but the code produced wasn't reliable because type checking. I'm not going to do it. The C compiler let things just go. Like if I define a function as expecting an int, and if in my code, I call this function passing a float variable or any other type, the compiler will just let it go. It didn't make basic check like that. Okay? So type check is important, but you may agree, you may say that, oh, but if a programming language has a lot of checkings, it cuts my freedom too, right? So again, you can't go too far, otherwise you're going to put the programmer, the developer, in very tight constraints. Everything. Have you ever programmed in Swift? Any of you Swift? So a little bit. So Swift, I don't know if they changed that, but I was. They asked me to teach mobile app development, and they wanted me to do it using. That wasn't here. It was when I was in Pennsylvania, and they wanted me to do using iOS, right? So I had to learn Swift, and they had just released Swift, and I had a hard time because in Swift, it was very the language has tight controls on typing. So if I even things that like, okay, the types are compatible. I'm trying to go from integer to float. Why can't I do that? Okay, float to int, I understand, but int to float, it should work, right? It require me to do casting, right? So very tight controls, and students hated all of that. It was really hard for them to learn how to obey all these checkings that the language required. I already mentioned that. Ariane 5 explosion was a big rocket. Nobody died because it was carrying a satellite, but it was a big explosion, and it happened because of the code written in C. The function that controlled the height of the rocket was doing a int sent to a float. Just what I wanted to do, right? I mentioned I need to float. I might have been the programmer, right, doing that. Yeah, so what happened is of course, because it wasn't me, it wasn't. The programmer probably was using an int to control the height, and the int flew and when it called I don't know the specifics, but it was a type conversion. Basically, the system realized because of this mistake that the height was lower than what was the actual altitude. So it went to auto destruction for safety. Exception handling is also important for reliability, right? The ability to, so the programming language having mechanisms to allow the program to do corrective measures when something wrong happens. Let's say try to open a file, the file doesn't exist. Anything that would crash your program, you have the ability to work around those problems, and be able to catch those exceptions, making your code more reliable. You don't want your code to crash, right? You want to know that something happened and do some countermeasures to work around the problem. Older programming language like C, for example, didn't have exception handling. So lots of times, many times the programs would just crash. Aliasing is the ability to use distinct names to refer to the same memory location. We do that a lot in, for example, Java. If you assign a reference variable to another reference variable, basically they're pointing to the same memory location, right? So you're creating aliases. It can be dangerous because you can lose control. You use one alias to make a change on that object, but then you, on the other reference variable, you thought it was pointing to another object, right? So it may create confusion. So that's something that may impact the reliability of your code. Not saying that aliasing is a bad thing. I'm just saying that that impacts reliability. All right, so let's get your cards. Let's see how much you guys were able to retain.
That's true.
There was
I left this year last class.
there's a little bit of buffer generated in this part of the class earlier. I don't know.
It can be a hive mind.
My virtual machine.
They aren't great at all.
Trying to get it into one factorial. It's not really What's up, man?
I can't see all the names on the screen.
What? Oh. It's back.
Get out of here. Maybe try dragging it.
Oh yeah, you should be able to click and just drag it over to the other corner.
Yeah, it looks like it's just in picture.
I can't see it anymore. There you go. I'm sharing my screen.
Yeah.
But okay, so
Is that a bar you can drag over?
Yeah, it looks like you can widen that.
still there.
Yeah, can you just drag over the bar where all the names are?
There you go.
But these,
There's still.
But there's still names that are
Oh, yeah.
obscured.
like, can you drag it over, make it wider?
Yeah, like a good old UI.
This is the teams, right? So I'm sharing here. So this is the team. No, this is the Explorer. I don't know where I am.
There we go.
wants to leave.
And the
Computer
department
science
wanted
class
me
based
to
on that
do
last moment.
stacking, which I have to do face-to-face and online at the same time. No way. Well, they didn't want me. They gave me the option. Good. So write less, do more expressivity. Okay. Okay, orthogonality. Intermultiplicity, 75%. Are you guys doing that by elimination? Because I saw like more than 90%. Not doubting that. 92%.
So close to the
One
parade.
of you. It's like free chocolate.
Come on, let's get this. 100%.
This one you should get 100%.
I agree. You really want to drive this point home.
Come on, let's do the parade.
We get one day, if we get 100%, we just go.
Simple language is power.
Now it's a big incentive, huh? 67. That's powerful. Doesn't mean it's less powerful.
Killing me.
Yeah.
Apparently not.
Um,
Time for the second one.
How's Scala going?
Oh, fun. Yeah.
It's fun?
It's beautiful.
Finished
Now that I've
homework
got it
Satisfying to see it come together.
set up correctly.
with the study sheet?
Is anyone else getting like?
Homework is due on Thursday, right? Any questions about Scala?
I figured out what I'm going to, but like,
Very
no.
That's usually.
Yeah. Yeah.
I know scale up.
Take a high ground.
Yeah.
Find a place to sit.
Walk through building, walks to. Yeah. Walking stations. Well, at least I'm not that worried.
More people will come up.
At least I'm not that worried. I wasn't talking about for the ACA.
Yeah.
It's a little, it's
You know, it's actually good. I saw the chart, I saw the to do, which is just, you have to visit the other file and then uses it to.
Okay, so it does the print statement correctly, and then it goes to display, and then it's correct. It's because I haven't. Whoa, you look like you're low on capacity over there, but. It's because I haven't actually parsed anything, so there's nothing stored to display.
I know they gotta answer files.
You've got to, but like, I mean, when I can do this to the phone,
With this one,
line in the
it's
screen, I
successfully
don't like.
removed.
I know they have some.
Successfully
I haven't looked at
shows the graph.
It is.